Welcome back. Today we're not traveling across continents or oceans, we're diving into the very fabric of reality. We'll explore physics so strange it feels like science fiction. Particles walking through walls, connections that defy distance, and time itself bending in ways that challenge everything we know. Our universe seems orderly. Planets orbit, apples fall, seasons turn. But zoom into the subatomic and those rules dissolve into shimmering probability and paradox. This is the quantum realm, where the building blocks of reality behave in ways that seem impossible. Here, a particle can be in multiple places at once, and just observing something changes its nature. Barriers become permeable, distance loses meaning, and time is surprisingly flexible. These aren't just theories, they're proven principles that power our technology and reshape our understanding of the cosmos. Prepare to have your perception of reality fundamentally altered. The quantum world is not just weird, it's the foundation of everything. Let's begin. In our everyday world, boundaries are absolute. A ball bounces off a wall, never passing through. But at the quantum level, particles like electrons don't act like tiny billiard balls. They're waves of probability existing in a cloud of potential locations. This wave-like nature leads to one of physics' strangest phenomena: quantum tunneling. Imagine a particle approaching a barrier. In classical physics, if it lacks the energy to cross, it's stopped cold. But in the quantum world, part of the particle's probability wave leaks through the barrier. There's a small but real chance the particle will simply appear on the other side, without breaking or jumping over the wall. It's as if you threw a tennis ball at a brick wall 1 billion times, and on the 1,000,001st try it just pops through, leaving the wall untouched. This isn't just a curiosity, it's essential to life itself. In the sun's core, protons face a powerful repulsive barrier. Classically, fusion shouldn't happen, but quantum tunneling lets them slip through, allowing the sun to shine. Every ray of sunlight, every plant that grows, owes its existence to this ghostly passage. Without tunneling, our sun would be dark, and life as we know it wouldn't exist. This phenomenon also shapes our technology. The transistors in your computer and phone are so tiny that electrons can tunnel through barriers, causing errors as we miniaturize further. But engineers have turned this challenge into an advantage. Devices like flash memory use controlled tunneling to store data. Electrons are deliberately pushed through barriers to represent ones and zeros. The ghost in the machine is now the foundation of our digital world. So next time you save a file or feel the sun's warmth, remember particles are constantly phasing through barriers, defying classical logic. Reality at its core is a shimmering tapestry of probability, not certainty. The solidity we experience is just an average of countless quantum events, each a tiny roll of the cosmic dice. Quantum tunneling isn't a flaw, it's a feature, and it powers both the stars and our technology. The universe is built on improbability, and the ghost in the machine is at the heart of it all. What seems impossible in our world is routine in the quantum realm. The next time you use technology, remember, you're harnessing the strangeness of the universe. Quantum tunneling is a reminder that reality is far weirder and more wondrous than it appears. It's not just a scientific oddity, it's the engine of existence. The boundaries we see are illusions, shaped by the quantum world beneath. Every moment, particles are tunneling, making the impossible possible. Our universe thrives on these ghostly passages. The next time you marvel at technology or nature, think of the quantum ghosts at work. The rules of the small shape everything we know. Quantum tunneling, the ghost in the machine, the secret behind the sun, and the heart of our digital age. The universe is stranger than fiction, and it's all happening right now. The quantum world is not just weird, it's essential. Embrace the strangeness, it's the foundation of reality. Let's see what other mysteries the quantum world holds. Onward. If tunneling challenges our sense of solidity, quantum entanglement shatters our ideas of separation. Einstein called it spooky action at a distance, and for good reason. Imagine two quantum coins entangled so their fates are linked. Separate them by galaxies, and still, the moment you observe one, you instantly know the state of the other. It's not just that you learn about the distant coin, the act of measuring one seems to set the state of both instantly, no matter the distance. This appears to break the cosmic speed limit, defying Einstein's own theory of relativity. For decades, physicists debated, is there a hidden layer of information, or is the universe truly non-local? John Bell's theorem and experiments by Aspect, Clauser and Zeilinger proved it. There are no hidden variables. The connection is real and instantaneous. The universe at its core is profoundly interconnected. Entanglement isn't just a philosophical puzzle, it's the backbone of revolutionary technology. Quantum computers use entangled qubits, which can be both 0 and 1 at once, to perform calculations that would take classical computers billions of years. Entanglement also enables perfectly secure communication. In quantum cryptography, entangled particles create secret keys. If anyone tries to eavesdrop, the act of measurement disturbs the system, revealing the intrusion instantly. The laws of quantum mechanics become the ultimate security guard, unbreakable by any hacker. So from a mystery that vexed Einstein, entanglement has become a cornerstone of 21st century technology. It reveals a universe more connected than we ever imagined, bound by invisible threads that defy our classical notions of space and separation. What is space if it can be so effortlessly transcended? What does it mean for two objects to be separate if their fates are inextricably linked? Spooky action at a distance isn't a flaw. It's a fundamental feature of our cosmos. The universe is a web of connections, not isolated parts. Entanglement forces us to rethink reality itself. The next generation of technology, quantum computers, unhackable communication, will be built on this strangeness. The quantum world is not just weird, it's the future. Every time you hear about quantum breakthroughs, remember, it's all thanks to spooky action at a distance. The universe is more mysterious and more unified than we ever dreamed. Entanglement is a window into a deeper reality. The boundaries between objects are not as clear as they seem. The quantum world connects everything in ways we're only beginning to understand. Spooky action is not just a curiosity, it's the key to tomorrow's technology. The universe is stranger and more wondrous than we ever imagined. Entanglement is the ultimate connection. The future is quantum. Let's keep exploring. Onward. We've seen how quantum physics bends our ideas of matter and connection. Now let's tackle time itself. We think of time as a constant river, flowing the same for everyone. But Einstein's relativity shows time is flexible, stretching and shrinking depending on speed and gravity. The faster you move, the slower your time passes compared to someone at rest. This is time dilation, and it's not just theory, it's measured fact. Imagine two people with synchronized atomic clocks. One stays on Earth, the other rockets near light speed for a year. When the traveler returns, they've aged less than the person who stayed behind. They've effectively leapt into the future. This isn't science fiction, it's been proven with astronauts. Scott Kelly, after nearly a year in space, was slightly younger than his twin brother on Earth. The difference is tiny, but real moving faster means living less time. Time dilation isn't just for astronauts, it affects us all every day thanks to technology. GPS satellites orbit Earth at high speeds and in weaker gravity. Their clocks tick differently than ours, slower due to speed, faster due to gravity. The net result, satellite clocks run about 38 microseconds faster per day than ground clocks. That tiny difference matters. GPS relies on precise timing to pinpoint your location. Without correcting for relativity, your GPS would be off by miles within minutes. Engineers pre-adjust satellite clocks and constantly correct for these effects, making GPS possible. Every time you use your phone to navigate, you're relying on Einstein's insights into the elasticity of time. Time isn't a rigid ruler, it's a flexible fabric shaped by motion and gravity. The universe's clock ticks differently for everyone, depending on where and how fast they move. The next time you check your location, remember you're experiencing the weirdness of relativity firsthand. Time dilation is not a bug, it's a fundamental law of nature. Our technology depends on understanding and embracing this strangeness. The flow of time is not universal, it's personal, shaped by your journey through space. The cosmos is a place where time bends, stretches and warps. Relativity isn't just for physicists, it's part of your daily life. The universe is more flexible than we ever imagined. Time is elastic and we're all travelers on its shifting currents. The next time you navigate, thank Einstein for your accurate directions. The fabric of reality is more malleable than it seems. Time dilation is a window into the true nature of the universe. The ordinary is built on the extraordinary. The elasticity of now shapes every moment. The universe is a dance of time and space. Embrace the strangeness. It's all around you. The future is shaped by the flexibility of time. Let's keep exploring. Our journey through the strange frontiers of physics ends here. We've seen particles tunnel through walls, entanglement connect galaxies, and time itself stretch and shrink. These aren't just equations, they're the universe's greatest magic tricks. The world of our senses is only a thin layer over a reality that's far stranger. The universe isn't obligated to make sense to us, but it rewards curiosity with wonder. Which phenomenon blew your mind most? The ghostly tunnel, the spooky connection, or the elastic nature of time? Let us know in the comments. And if you enjoyed this dive into the weirdness of reality, subscribe and hit the bell. We explore the cosmos's most mind-bending science every week. Until next time, stay curious, the magic show continues.